Hi, welcome to Science Chomp. Today we're going to be looking at making images from convex mirrors. First of all, before we look at actually how to make an image, we need to know what happens to the light. So we're going to need a set square and a load of pens. So what I've got drawn here, I've got the convex mirror itself. I've got the optical axis, sometimes it's called the principal axis. I've got the focal point here. This length from here to here, this is the focal length, and this is 2f, so this is double the focal length. Sometimes people call that C for the center of curvature. It's exactly the same. So what I want to do is I want to put my set square against the optical axis like so. Put a ruler up against it, and this is going to allow me to slide and make perfectly parallel lines, if I'm careful, that is, anyway. Okay, so my first line, this is going to be a ray of light going parallel to the optical axis, like so. Give it an arrow, so it gives it a direction. And this reflects off of the mirror at this angle. So you've got to start off from here, and it bounces off like that. Okay? Now, what I like to do is I actually like to make some dotted lines, so you can actually see at what angle the ray of light is bouncing off. So that's the first thing, and it doesn't matter where it is on the mirror, as long as it's parallel to the optical axis, it's going to bounce off at the angle coming from the focal point. So let's do another one. So we'll do one going like this. Okay, and then what we do is we go from here, the focal point. You've got to be a little bit careful here because I'm using quite thick pen, so the accuracy isn't the best, but hopefully you get the idea. So a parallel line is going to, parallel ray of light is going to be bounced off at an angle from the focal point. Okay, we'll do another one just so that you get the idea, right? So put it against here like so. I'll push it all the way down there. Make my ray of light. And then from the focal point, like that. So anything going parallel to the optical axis gets reflected like that. And as you can see, all the light rays are kind of moving apart, and it's kind of what we call diverging. Okay, that's the first thing. The next thing that you need to know is if there is a ray of light that is going in an angle towards the focal point. So let's just draw that. Okay, so I'm aiming towards the focal point over here, and my ray of light is going in that direction. Okay, what's going to happen to this? Well, it's basically the opposite of one of these ones, so it's going to be reflected parallel to the optical axis. So again, we've got to do this thing with this set square. Like this, so it just gets reflected parallel. Just messed up a little bit there, but you get the idea. Okay, so anything that's going parallel to the optical axis is reflected away from the focal point, and anything which is going towards the focal point is going to be reflected parallel to the optical axis. I know my diagram's a bit poor, but hopefully you get the idea, and you should see on the screen a well-drawn computer-aided diagram. Okay, so now let's have a look what happens when you have an object and you want to get an image from it. So my object is going to be this arrow over here. Badly drawn arrow, just like everything that I draw is quite badly drawn. But anyway, it's an arrow, it's an object. So what you want to do, first of all, is get a ray of light going parallel to the optical axis. So again, I'm going to use this. Put this against the principal axis, the optical axis, like so. Try and be as accurate as you can. Just move it like that. And this is going to be my first ray of light. Going from the top to the mirror, like so. Okay? And anything going parallel to the optical axis, it gets reflected at an angle that is away from the focal point. Like this, okay? I'm going to make a dotted line all the way down to the focal point so you can see what I've done. Okay? So that's the first ray of light. The second ray of light, I am going to aim it directly at the focal point itself. Like so. Just do a dotted line all the way down to there. Give an arrow. And of course, this one is going to be reflected parallel to the optical axis. And it's reflected parallel all the way out like so. Now, the idea is when you make an image, what you've got to do is you've got to make the reflected rays meet. Now, it's not going to meet on this side of the mirror because the rays of light are diverging. So they actually form behind the mirror itself. So what I want to do is I want to extend this reflected ray. So I'm going to do another dotted line. Ooh. Like so. Okay? And where the blue dotted line and the red dotted line meet, that is where the image is formed, the top of the image over there. So it ends up forming kind of like that. Now, as you can see, it is an upright image. It is a virtual image because it's actually made out of non-existent rays of light. These dotted lines, they don't actually exist in real life, but they give a virtual image like this. So it's an upright, virtual, smaller image. So I'll write that over here. So it's upright, smaller, virtual image. Okay? And that's it for convex mirrors. Thank you very much for watching. I'll see you in the next video. Just a quick handy tip. If you're taking an exam and you know you've got to deal with concave and convex mirrors, bring a spoon in. I mean, technically it's not cheating, but what you have is you've got a concave side over here and a convex side, and it being a mirrored surface, you can actually see what happens to the image. So when you hold a spoon like this, you can see it's an, on the convex side, you can see it's an upright, smaller image. And over here, you can see at this distance, it's an upside down, smaller image. And when you bring it really, really close, the image changes. So if you can get away with it, bring a spoon in. It will just help you answer some of the questions if you can't remember some of the finer details.